Imagine you're running this really high-end hotel, right?
Okay, I'm with you.
And you want to attract that growing demographic of electric vehicle owners. So you decide, you know what, I'm going all in.
Naturally, you want the best of the best.
Exactly. You drop like over $250,000 on a bank of the absolute fastest, top-of-the-line, 240 kilowatt fast chargers.
Oh, wow.
Yeah, you install them right in your parking garage. You're expecting this massive return on investment. But according to a new business planning report from Luxman Energy, you have just made one of the most catastrophic financial mistakes of your career.
Yeah. I mean, it is a phenomenal way to just burn capital.
Right.
And the crazy thing is, it happens all the time because, we're trying to apply this century-old mindset to a completely new paradigm of energy distribution.
Exactly. Well, welcome to this deep dive. Today is July 31st, 2026, and our mission today is to just cut through the noise of the EV revolution.
Because there is a lot of noise out there.
So much noise. We aren't talking about, dashboard touchscreens or 0 to 60 times today. We're exploring the massive, chaotic, and honestly largely hidden infrastructure war that's happening right behind the scenes just to keep these vehicles moving.
Yeah, because the reality is the vehicles themselves. That's the easy part.
Right.
The real frontier, like the place where fortunes are literally being made and lost right now, is the logistics of the charging network.
Absolutely. And to navigate this, we're pulling from a pretty massive stack of sources today.
We've got a lot to cover.
We really do. We've got a 2026 industry prediction report from DriveIs, that Luxman Energy business planning guide I just mentioned, and some legislative analysis for California's Assembly Bill 2543.
Plus some really interesting startup stuff, right?
Yeah, exactly. Startup funding press releases from Be-Charged EV and Spark Charge. Oh, and this fascinating pair of April 2026 reports detailing New York City's municipal fleet electrification.
That NYC data is wild.
It is. Okay, let's unpack this. I think the core assumption we have to break first is this idea that charging a car is just, a modernized version of pumping gas.
Right, because we like our infrastructure to be standardized,
Totally.
We're used to the binary nature of a gas station. Your tank is empty, you pull in, you fill up in maybe 5 minutes, and you leave.
But the sources make it super clear that going to a gas station is essentially like going to a fast food drive-thru.
Exactly.
I mean, the restaurant's entire profit model relies on getting you away from that window as quickly as humanly possible. But EV charging, it's more of a spectrum.
It really is. It requires business owners to figure out, is my parking lot a fast food drive-thru, or is it a slow sit-down dining room?
That is the perfect way to look at it. And I guess that brings us right back to that hotel example from earlier.
Yeah, the Luxman Energy Guide introduces a foundational concept here, and they call it dwell time.
Dwell time.
Okay, right. It's simply the calculation of how long a vehicle is expected to remain parked at a specific location. So if you put a massive, highly expensive 240 kilowatt fast charger at a hotel, you are completely ignoring dwell time.
Because the guest is sleeping, like they're parked there for 8 to 12 hours.
Exactly. The car doesn't need to be charged in 20 minutes if it's just going to sit there all night.
That makes so much sense.
Yeah, by installing that fast charger, you spent all this massive upfront capital on the hardware, plus grid connection upgrades, and it's just going to sit idle for 11 and a half hours a day. It totally ruins your return on investment.
So for those long dwell times like hotels, apartment buildings, workplace parking lots, you actually want standard level 2 AC chargers.
Precisely. They're cheap to install, and they're gentle on the grid.
And the ultra-fast DC chargers, the ones pushing anywhere from 60 to 240 kilowatts, those are your drive thrusts.
Exactly. They belong on highway corridors or, in commercial fleet depots where rapid vehicle turnover is literally the only way the math works.
Which introduces this new metric that the entire industry seems to be obsessing over right now. The DriveIs report calls it profit per kilowatt hour.
Right, because a charger only generates value through constant appropriate utilization.
But maximizing that profit metric isn't just about picking the right hardware, is it?
No, not at all. It is deeply tied to how you actually interact with the local electrical grid.
Right, because you can't just, just drop 50 fast chargers into a depot and expect the local neighborhood grid to just not immediately melt down.
Exactly. And utility companies protect their grids using something called demand charges.
Okay, break that down for me.
So if you're a commercial property and you draw a massive spike of power during peak times, say, I don't know, everyone plugs in their fleet at 5:00 p.m. when the whole city is running their air conditioners, the utility hits you with exorbitant fees.
Wow.
Yeah. A single 15-minute spike in power usage can trigger demand charges that wipe out a charging operator's profit for the entire month.
For the whole month, just from a 15-minute spike.
Literally one spike can ruin the monthly balance sheet.
So how do you even avoid that? I mean, if a fleet 50 delivery vans returns to the depot at 5:00 p.m., you have to plug in, right?
Well, this is why artificial intelligence has become absolutely non-negotiable in this space.
Oh, of course, AI is everywhere.
According to the Drivers Report, 80 to 90% of organizations in EV charging are utilizing AI right now.
That's huge.
It is. In EV charging, AI acts as this sort of invisible air traffic controller for electricity. When those 50 vans plug in at 5:00 p.m., the AI doesn't just open the floodgates.
So what does it do?
It looks at the grid's current load, it checks the utility's pricing tiers for that exact moment, and it actually looks at the telematics of the vans to see, oh, van number 3 doesn't actually need to leave until 6:00 a.m. tomorrow.
Ah, so it feathers the power. Like it might just trickle charge them or wait entirely until 2 a.m. when power is dirt cheap just to avoid that demand charge spike.
Exactly. It dynamically balances the load. And all of this complex management relies on a digital backbone. You'll see the acronym OCPP constantly in the Luxman Guide.
Right, OCPP, Open Charge Point Protocol. It honestly reads like the operating system of the entire EV infrastructure world.
It essentially is. OCPP software allows the central hub to talk to any brand of charger.
Okay.
It manages that AI scheduling, it handles complex billing across different user tiers, and it provides remote monitoring. So like, if a cable is faulty, the system flags it before a driver ever pulls up and finds a broken machine.
Okay, so if you're a fleet manager, you pick the right charger based on dwell time, and you set up this OCPP software and AI to avoid those crazy demand charges.
Right.
But reading through these sources, there's this massive physical roadblock here.
Oh, the grid upgrades.
Yes. Getting the local utility company to actually upgrade the physical grid like laying the conduit, upgrading the transformers to handle a new commercial charging hub, it can take 18 to 24 months.
It's brutal.
Put yourself in the shoes of a business owner. If you want to electrify your fleet today, waiting 2 years for a permit and a transformer upgrade basically means your business is paralyzed.
It is the single biggest bottleneck in the industry right now. But it's also prompting some of the most disruptive innovations we're seeing.
It honestly reminds me of the shift to cloud computing.
How so?
Well, think about it. Like 15 years ago, if a company wanted to scale up its digital operations, they had to build their own physical server farm.
Oh, right. Massive upfront cost.
Exactly. It was a huge capital expenditure, a CapEx. But now, nobody builds server farms. They just use AWS or Google Cloud. They pay for exactly the computing power they use as a monthly operating expense, an OpEx.
And you're seeing that here.
Yeah. Based on the funding data from SparkCharge and B-Charged EV, we are seeing the exact same financial model applied to electricity. It's charging as a service, or K.
What's fascinating here is how entirely this bypasses the utility company.
Right.
These startups are literally saying, hey, don't wait 2 years for the grid to come to you. We will bring an off-grid microgrid directly to your parking lot.
Look at SparkCharge. Their literature claims they can deploy a massive charging as a service hub to a site in as little as 7 days.
7 days.
7 days versus 2 years. And they do this using what they call power hub generation.
Right, which is huge.
It's off-grid power pushing over 5 megawatts of output, paired with battery energy storage systems, or BES, that hold over 1,000 kilowatt hours of capacity.
It's wild.
They just drop these modular systems at a fleet depot or like a construction site with zero upfront CapEx cost to the business.
It completely shifts the financial risk. The fleet operator just pays a subscription or per kilowatt fee for the energy delivered, just like an AWS cloud bill.
Exactly.
But the innovation isn't just massive stationary batteries. It's the mobility and the intelligence of the deployment. Look at B-Charged EV.
Yeah, they just got a bunch of funding, right?
Yeah, they just secured $7 million in funding. And $3.2 million of that is dedicated specifically to physical charging equipment, so they can scale their commercial mobile fleet from 100 units up to 1,000 across the U.S. and Mexico.
And their tech goes way beyond just, driving a battery to a parking lot. B-Charged uses a platform they call PSC AI, which stands for Predictive Smart Charging.
Right, and to understand why this matters, you really have to look at the mechanism.
Okay.
PSC AI integrates directly into a commercial fleet's routing software and the vehicle's internal telematics. It knows the exact route the delivery van is taking, the topography of the road, the payload weight, and the real-time battery drain.
Wow. So it's not waiting for the driver to call a tow truck because they ran out of juice on the side of the highway?
Exactly. If the AI calculates that van number 4 won't make it back to the depot based on its current route and load,
Mm.
it autonomously dispatches a mobile B-charged unit to intercept that van at its next delivery stop.
That is incredible.
Yeah, with one tap, the infrastructure comes to the vehicle before the driver is ever stranded. It transforms fleet management from reactive panic into a proactive system.
And it's not just for corporate fleets either. Be Charged has this program called Apex 300 that specifically targets what they call charging deserts.
Right, the underserved areas.
Yeah, these are communities that traditional fixed infrastructure companies have completely ignored because, laying the grid there just wasn't immediately profitable.
Yeah.
The Mexico City launch they highlight is incredible. They're servicing rideshare drivers with mobile units that output 65 to 70 kilowatts.
Which is really fast for a mobile unit.
Right. That gives those drivers a full charge in 20 to 30 minutes, right where they are working. That is vastly faster than whatever sparse local infrastructure is available to them. It's literally giving them hours of their working day back.
It just demonstrates the flexibility of this model.
Mm.
When you decouple the charger from the physical grid, you can actually solve geographic and economic disparities in real time.
We're talking about using these mobile chargers to rescue stranded delivery vans or service rideshare drivers. But if we follow this logic, decoupling from the grid isn't just a clever business model for tech startups.
No, it's becoming essential.
Yeah, in some environments, it's a matter of sheer survival, which brings us to the legislative analysis of California Assembly Bill 2543.
This is where the vulnerabilities of the electrical grid really intersect with public safety.
Okay, but I have to push back on the premise of this bill a little bit because reading the analysis, there seems to be a massive double standard here.
Okay, let's hear it.
AB 2543 mandates strict emergency management plans for EV charging stations. But traditional gas stations aren't required by law to have emergency backup plans to stay open during a disaster.
That's true.
If a hurricane hits, a gas station owner can just lock the doors and evacuate. Why is the EV station operator suddenly the only one on the hook for keeping the transportation network alive?
It's a very common point of friction in the industry. You're not wrong. But staying entirely impartial about the politics of the bill itself, the legislation is driven by the physical realities of how energy is delivered.
Okay, what do you mean?
Well, think about the mechanism. Gasoline is physical matter. It can be stored in underground tanks for weeks. Even if the grid goes completely down, a simple, low-power portable generator can run the mechanical pumps to get that gas into a car.
Right, it just needs a tiny bit of power to move the liquid. But an EV charger doesn't store energy. It's literally just a conduit.
Precisely. It requires real-time, high-voltage electricity delivery. If the grid drops, the fuel simply ceases to exist on-site. And in California, the grid is uniquely vulnerable.
Yeah, the wildfires.
Exactly. You have extreme weather, and you have public safety power shutoffs, or PSPS, where the utility intentionally cuts power to entire regions just to prevent transmission lines from sparking wildfires.
So an EV driver in an evacuation zone could find themselves completely stranded with zero options.
Exactly. And the baseline reliability of public chargers was already a huge point of contention. The legislative analysis relies on a 2022 UC Berkeley study, which found that on any given day, 28% of public DC fast chargers in the Bay Area were broken, unresponsive, or just inaccessible.
28%. That is a huge failure rate.
It is. That unreliability is actually what prompted the federal NEVI program to mandate a strict 97% uptime requirement for any federally funded chargers.
Wow.
So AB 2533 basically takes that baseline anxiety and applies it directly to disaster scenarios.
So how does AB 2543 actually mandate resilience? Like, how does it work mechanically?
First, it requires the state's Office of Emergency Services and the Office of Energy Infrastructure Safety to map the state and determine which specific DC fast charging stations are critical.
Based on what?
They evaluate population density, geographical isolation, the sheer number of chargers at a site, and the distance to the next available fast charger.
Okay, and if your site is deemed critical.
Then you, the operator, must submit an emergency management plan proving you have backup power. And crucially, the bill explicitly designs backup power to include the deployment of mobile chargers, like the B-charged or spark charge units we just discussed.
Oh.
Yeah, you don't necessarily have to install massive, dirty diesel generators. You can just contract with mobile fleets to ensure your site can still push electrons when the utility cuts the lines.
And we know this works. The source materials highlight a massive precedent for this.
Florida, right?
Yeah. During Hurricane Milton, the Florida Department of Emergency Management actually deployed temporary mobile EV charging hubs along the major evacuation
That's
routes.
just brilliant.
They essentially created pop-up infrastructure to ensure EVs fleeing the storm didn't just die on the highway.
It really shifts mobile charging from a corporate convenience to a critical component of civic resilience.
Okay, so we've explored the economic models, the predictive AI, the off-grid startups, and the disaster legislation. But I want to take all of this theory and put it through the most extreme, punishing, daily operational stress test imaginable.
Let's do it.
Because a stranded Amazon van is one thing, but what happens when you electrify a police chase?
Oh, man.
Like, you can't exactly ask a fleeing suspect to, sit tight for 30 minutes while your squad car recharges.
Right. It is the ultimate proving ground. For that, we look to the April 2026 Clean Fleet Transition Report from New York City.
Yes, this report was fascinating.
The data coming out of NYC proves the viability of EVs in highly specialized, high-stress applications that most people assumed were years away from electrification.
The scale of what New York is doing is staggering. According to the report, NYC just surpassed 1,000 electric vehicles in law enforcement alone. That makes it the largest electric law enforcement fleet in North America.
It's massive.
The NYPD itself operates nearly 500 of them.
And we aren't talking about, meter maids and golf carts here. They're deploying the Chevy EV Blazer, which is the city's first pursuit-rated electric vehicle.
Right.
But electrifying a police fleet isn't just about taking out the gas engine and dropping in a battery. The report goes into detail about the massive physical modifications law enforcement vehicles require and how that completely changes the physics of the car.
Right. You have to up-armor the doors with bulletproof shielding. You have to install interior partitions, heavy-duty suspension, complex radio and computer outfitting, and massive light bars and sirens.
It adds up fast.
All of that destroys the aerodynamics and adds tremendous weight to the chassis.
And in the EV world, weight and drag are the absolute enemies of battery life.
Though, I'm sure.
Every pound of ballistic glass drains the battery faster during a pursuit. And the internal computer systems and the light bars constantly draw high voltage power, even when the vehicle is just, idling at a crime scene.
Which circles back perfectly to the infrastructure piece. Because of that heavy battery drain, you can't rely on slow chargers. The infrastructure must be perfectly matched to the patrol shift.
Exactly.
NYC now operates over 415 fast chargers just to support these intensive use cases. And across the entire city government, they operate a municipal fleet of nearly 10,500 electrified units. We're talking 5,825 full EVs and over 4,600 hybrids. Even the city's forklifts are going electric.
But, the report does highlight a pragmatic exception, a sort of structural curveball to the fully electric mandate.
Yes, the extended range EVs. I found this fascinating.
Yeah, extended range EVs operate primarily as electric vehicles, driven by the electric motor, but they feature a small internal combustion engine backup on board that acts solely as a generator for the battery.
So they still take gas, but just to charge the battery.
It's exactly. The report notes that for incredibly heavy-duty municipal tasks like plowing snow for 24 hours straight, heavy towing, or continuous emergency response where stopping to charge is physically impossible, this hybrid approach is the only way to solve the immediate operational demands.
While still drastically reducing emissions the rest of the year.
Precisely.
And there are unexpected safety tie-ins with this entire electrification push, too. Because the city is essentially redesigning its fleet from the ground up to accommodate these heavier battery packs, they are baking in new safety techs simultaneously.
It's a great opportunity for an overhaul.
Right. The report details the inclusion of intelligent speed assistance, high-vision truck designs to reduce blind spots, and side guards to protect pedestrians. They are offsetting the dangers of heavier vehicles with much smarter vehicles.
It is a truly holistic redesign of how a massive municipality operates its physical assets.
We have covered an immense amount of ground today. We started with the economics of dwell time and AI demand management, moved through the AWS model of mobile power, navigated California's disaster prep, and rode along with the NYPD's pursuit vehicles.
That's a lot to take in.
It really is. As we wrap up this deep dive, I want to hand it over to you. Looking at all these diverse sources, what is the one overarching concept, the big takeaway that points to where this infrastructure war is ultimately heading?
Well, if we connect this to the bigger picture, there is a concept buried in the driver's report that fundamentally flips everything we've discussed today on its head.
Oh,
Up until now, our entire conversation and society's general view, really, is that cars are consumers of energy. They take power from the grid.
right. That's what a car does.
But the future of this infrastructure is a technology called bidirectional charging, or V2G, vehicle to grid.
Okay, break down the mechanics of that. How exactly does a car give back?
V2G technology allows those massive EV batteries to not just receive power, but to actually push their stored power back out into the grid when needed.
Whoa.
Now, apply this to everything we've talked about. Imagine that fleet of 1,000 NYPD police cars, or a massive lot of 500 delivery vans. They charge up at 2 a.m. when power is dirt cheap and demand is low.
Okay.
But at 4:03 p.m. the next day, there's a massive heat wave. The city grid is struggling, air conditioners are maxed out, and energy prices are skyrocketing.
Okay, I see where this is going.
When those vans are parked, they aren't just a dormant transportation fleet anymore. Through the OCPP software and AI, the fleet operator can flip a switch and turn those 500 vans into a virtual power plant.
A virtual power plant.
Yes, they discharge a portion of their stored energy back into the city grid.
So the fleet manager is buying energy at night for pennies and literally selling the energy sitting in their parked cars back to the energy market in the afternoon at a premium.
Exactly. It creates
Yep.
massive financial arbitrage. The vehicles become a revenue stream that offsets the cost of the fleet.
That is wild.
Or, looking back at our California disaster scenario, they can use vehicle to home, V2H. If the utility initiates a public safety power shutoff, a business or a homeowner can actually draw power from the vehicles parked in the driveway to keep the lights on and the refrigerators running.
The vehicles literally become the backup generators mandated by the state. That is a massive paradigm shift. The car isn't just a method of transportation anymore. It is a mobile, intelligent battery that is actively rewiring the economics and the physical reality of how the world manages energy.
It completely redefines what a vehicle is.
It really does. Well, thank you for joining us on this deep dive. As you head out today, take a fresh look at the cars on the road. Remember that opening thought we had about the simple, uniform gas station transaction? The reality of the EV transition is anything but simple, and it certainly isn't uniform.
Not at all.
It's a chaotic, wildly complex frontier. But through AI load balancing, mobile deployment, and bidirectional charging, that chaotic frontier is slowly being woven into a brilliant living energy network. The infrastructure war is happening right now behind the scenes, and the vehicles parked in your driveway are on the front lines.